Okay, so Naomi, we're going to cover loops today, and we're going to go over some multiple choice questions and then do a free response. Does that sound good?
Sounds good.
How familiar or how comfortable are you guys with writing your for loops and while loops?
Probably more comfortable with like for loops and while loops, just because that's what we usually use.
Yeah. Okay. So you guys all are familiar with them, right? Though?
Yes.
We can dive right into some multiple choice questions. Hi, Donnie.
Sure.
Okay, I'm gonna share my screen with you guys.
Cool.
Boom! That was not meant to
Happy
happen.
Halloween.
Let's see. Let me share my screen. Okay.
And the ebook link is in the chat if you want to follow them.
Okay, cool. So we can jump right in. So the following says, how many stars are outputted when the following code is executed? So this is just a nested for loop. Do you guys want to work it out yourself and then type your answer in the chat window, and then we can go over it?
Okay.
Yeah, and when you think you get it, just just type your answer into the chat window. Okay, awesome. So all of you guys said C. Who wants to explain it? You guys are right. Let's check it. Yeah, cool. So yeah, who wants to explain it? Naomi, how did you get C?
I just saw that the first one ran 5 times. Second one ran 5 times. I just multiplied 5 times 5.
Yeah, exactly. So yeah, for each time I is some integer less than 5, J is going to run 5 times. Cool. Anyone have any trouble with that one?
No.
Okay, yeah, we can go to the next one.
I'll be right back.
Okay, sure. So we want to display this output. It's sort of like a pyramid. And on each line, the number, like the line number is repeated not many times. So on the first line, you repeat the number 1 time. On the second one, you repeat that number 2 times, and then so on. So we have to look at this code and see which one would display the correct output. Okay. Do you guys want to work this out too?
Sure.
I'm back.
Johnny, are you there?
Oh, he said he'd be right back like a few seconds ago.
Okay.
Wait,
Kogi,
he is
here.
Never mind.
Oh, okay, yeah. Yeah, let's give him a second to enter it.
Oh, no.
Okay, Isabella, do you want to explain how you got 1?
Yeah, so, well, first of all, for it to print I correctly, it has to start at 1, so that I has to start at 1, so that eliminates 2 and 5.
Yeah. Good thinking. Yeah.
And then it has to run 1, 2, 3, 4, and 5, so that eliminates 3. And
That eliminates. What do you mean? So how is 1 and 3
Wait.
different?
because for 1, int I starts at I is 1, and then it says less than or equal to 5, so
Okay.
it'll go, but for 3, I is less than 5, it'll stop after 4.
Okay.
And then, wait. Wait, no, for some reason I didn't see number 4, I just skipped over it. It's not 1.
Oh, you think it's 4? Why do you think it's 4?
Wait. Wait.
Yeah, walk through it. Walk through 4.
Because the number of I, like, the amount I increases, so it can't be 1 because it says J minus minus, and that'll make it an out of bounds error.
It'll make it an out of bounds error. So in I,
Right?
so in the first one, in the
Wait.
second for loop, J starts at 1.
Yeah.
Or it starts at whatever I is, right?
Wait, no, it'll just stop after 1. It won't continue to run.
It'll
Wait.
stop, yeah, because of the decrement, because of
Yeah.
here, it's decreasing, right? But
If there would.
I is always increasing because of the first for loop.
Oh, yeah. Wait.
So let's walk through each of them. Let's walk through 4.
Yeah, I didn't see 4. I thought 4 was like another one of the like zeros, so I kind of
Sure.
skipped over it. So
So the first for loop seems right. It goes from 1 and it'll stop at 5, right?
yeah.
For the second for loop, so I starts off at 1, J starts off at 0, and then while J is less than I, print I. So that works. Let's go through it. So I is 1, J is 0, 0 is less than 1, and so we're going to print 1. Does that work?
Mhm.
Okay, so then J becomes 1, and then it breaks out of this while loop. I mean, this
Yeah.
for loop, and then we go back to the first for loop.
Mhm.
What is I then?
Then I is 2.
Okay, so take me through what happens when I is 2.
Then int J is 1.
So J starts up again at 0, right?
Oh, it's still, yeah.
Yeah.
It starts again at 0. And then it prints 2.
So it prints 2 once, and then so J was 1 and it printed once, and then J becomes 2.
Yeah.
Yeah, and it goes back and prints 2 again.
Mm.
Okay, and so then now J is 3, but that no longer works in the for loop, so we go back up to the first one.
Yeah.
And J is now 3. I is now 3.
Mm.
Okay, so it looks like that works, right?
Yeah.
Naomi, can you explain number 1 to me?
I, yeah, or like one.
Yeah, sorry, yeah,
I don't know what it was. Number 1. So I chose this one because it was the only choice in the first for loop. It had I is greater equal to 5, and we actually need 5 to be able to complete the pyramid. So
Sure.
it'll go through the first one, and 1 is greater than 5. Then it'll go to the second one, 1, and then 1 is greater than 0, and then J minus minus. but we don't have to do that. It just prints 1 afterwards.
Mhm.
Then it will go back, and then it will -1, and that'll be 0.
Yeah, so then it'll break out.
And j will not equal, is not greater than 0, so go back
Mhm.
to the first one. It'll be I is now 2.
Mhm.
And then it'll just go on from there. And it'll print 2 times because 1 is still greater than 0. Yeah.
Yeah,
With
you're right.
2.
2 is still greater than 0, and then it'll print that twice.
Yeah.
So in terms of the first for loop, both the for loop of 1 and 4 both work. Because this one says I is less than 6. So it will print everything up to 6, including 5. Right?
But doesn't
Yeah.
have another line though.
Hmm?
Print line.
Yeah, that's the difference. So that's why 4 isn't right, because we're missing this print line at the end of the second for loop.
Yeah.
So this would just print in one line. It wouldn't print in a pyramid.
Yeah.
Yeah. And 4 also, actually, never mind. 4 prints vertically. It prints a new line after each one.
Yeah.
So it's still not the pyramid shape, right? Yeah.
Yes.
So it's
Okay.
1. Yeah, got it?
Mm-hmm.
I didn't realize it was asking for like the pyramid shape. I thought it was just like asking for like the numbers themselves.
Yeah, but the 2 for loops are correct for both. Donnie, do you think you get it? Should we go over it again?
Could you please?
Hmm?
Yeah, that would be great.
Okay, so Isabella or Naomi, do you want to explain it to Donnie once more? Number 1, why number 1 is right?
Number 1 is right because for your first line of code that you want to print is going to just be just 1, just like 1, like number 1. And then so when we go through the first for loop, it'll be int I equals 1, and I is less than or equal to 5, right? So then if I goes on to the second for loop, and then int j equals I, so it'll be 1. 1 is greater than 0, and then it prints out 1, and then it goes back to the other for loop, and it decrements 1 will be 0. And 0 is not greater than 0, so it does not fulfill that requirement, so it goes back to the first for loop, and then it keeps on doing that. So I will be 2 now because we incremented it. So yeah.
Yeah, and then we always do a print line after each, like every time I changes.
Yeah, we do print line every time I changes, yeah.
Mm-hmm. Does that make a little bit more sense?
Okay, that makes more sense now.
Yeah, so I think a lot of students might get confused because they're used to seeing like I++ or J++, but starting at like setting J to I and then decreasing it until you get to 0 also works.
Yeah.
Okay, cool. We can go to the next one. So this is a for loop with a conditional inside. So again, you guys can work it out yourself and then put your answer in to the side. Okay, cool. E, let's check it out. Okay, cool. Donnie, do you want to explain it?
Okay. So what I did was first 0, that thing 3 does not equal 1. So that cancels out A and C. Then it increments by 2, so it can't be D because that's a 1. And so you're left with B and E. So I just did 10 the thing 3 and that equals 1. And since that one has those answers, whatever, that one works.
Yeah, so it's finding, yeah, you're exactly right. So it's finding all the numbers from 0 to 20 that when you divide by 3, the remainder is 1. So it is all like D, it is all D, but we have to remember that it increments by 2. So it's going to be all of those all of those numbers that when you divide by 3, the remainder is 1, but that are also even because you're always incrementing by 2.
Mm-hmm.
Okay. Hi, Landon. Thanks for joining us.
Hi.
We're just doing some multiple choice questions with for loops. So, okay, here's the next one. And it's similar to the one we just did, but instead we're printing a pyramid with 5. So on the first line, we're printing 5 ones, and then we're printing 1 less of each number. So which one will produce the output? So yeah, work it out yourself real quick, and then you can put your answer in the chat bar.
All right.
Yeah.
Hi, Bia.
Hello.
Hey, Bia, we're working on multiple choice questions with for loops and while loops. So this is the question we're on right now. You can join in by just typing your answer into the chat bar.
Okay.
Give it one more minute, and then we'll go over this answer. Okay, so let's check A, since most of you guys said that. Okay, you're correct. Nice. Does anyone wanna explain why they got A? Isabella, do you want to walk through this one?
Yeah, so J starts at 1, and so all the first for loop is the same. So it all starts at 1. And so K starts at 5. And K has to be greater than J because J starts at 1, and if K is less than J, then it won't run
Okay.
because K starts at 5. But then, okay, so you start at K, and you will print J as long as K is greater than or equal to J. So when it's 1, it'll print 1, then K will become 4, it'll print 1, K will become 3, it will print 1, K will become 2, it'll print 1, K will become 1, it'll still print 1. And then
Okay,
it'll go
great.
back, and then it will subtract from K,
Okay.
and then go, and it'll do it again.
Yeah, and then we are definitely getting the pyramid shape because of the print line.
Yes, with the print ln.
Yeah, so it's important when you do nested for loops because they can be pretty confusing sometimes to identify what each variable represents. So in the first for loop, int j, what does that represent?
It's the number being printed.
So it's the line, and it's the line number, right? So in this case, we're printing at line 1, number 1, at line 2, number 2. And then what in the second for loop, what does the int k represent?
The number of like the number of like the numbers in the line.
Yeah, exactly. The number of times you'll print each number in each line.
Yeah.
Yeah. So I think as long as you can identify those, you have a good handle of what this nested for loop is doing. Okay. Does anyone have any questions on this one?
Okay, I have a question.
Sure.
So like, what causes the difference between number 1 and 2?
Number 1 and 2.
It's the greater than or equal to 1, but like, why?
Number 1.
So, yeah. So the difference is in this, in the second for loop in the end condition. So can someone who said A want to explain why, or go walk through 2 and see what would happen in this case when you say K?
Yeah. So if K is greater than or equal to 1, K starts at 5, and so when K is 2, it'll keep printing 2 5 times until it gets to 1, and it'll go through it and it'll print 3 5 times. So it doesn't decrease the number of times the numbers are printed, and it just stays constant with 5 per number.
So for instance, when in this one, when we say K is greater than or equal to J, when J is 5, when it's at the last line of the for loop, K will only print it once, right? But like it was just said, if it's greater than or equal to 1, it will keep printing. Or it will print 5 times, right? Because like the second for loop is always done 5 times.
Oh, okay. I understand
Yeah.
now.
Okay, does anyone else have any more questions on this question? Okay, cool. Let's go to the next one. This is the last one, and then we'll start the FRQ question. Hey, Maggie, thanks for joining us. We're just going to put in your answers in the chat window, and then we'll discuss the question afterwards.
Okay.
Let's give everyone one more minute and then we'll go over this answer.
Um,
Okay, so it looks like there is some confusion or some differences in this one. Let's try D. That's the most popular. Okay. So to someone who got D, want to explain? Landon, do you want to give it a shot?
I guessed, but I knew it was like either like I got like A or D, but I'll be honest, I
Okay, sure. Does anyone else want to give it a shot and explain?
So like, I basically just decreased variable 2 until it didn't work anymore, and that was 2 times. And so when after 2 times it was 0, so variable 2 equals 0, then variable 1 increased 2 times, which makes it 2.
So how did you know to only do it twice?
Because after variable 2 decreased 2 times, it equals 0, and the while loop can't equal 0 for variable 2.
Oh yeah, so that's one of the stop conditions of your while loop. We have to also be wary of the second stop condition. So this is when bar1 divided by bar2 would be less than 0. So would it be negative? And that would be possible if like bar1 decreased below 0 at one point, right? So yeah, we can like go through it. So bar1 is 0, and bar2 starts off at 2. So while bar2 is not 0, which it isn't, and while bar1 divided by bar2 is greater than or equal to 0, so in this case it's 0 divided by 2 is greater than 0, which it is. We increment bar1 by 1, and we decrement bar2 by 1. So after the first run through of the while loop, bar1 is 1 and bar2 is 1. Does everyone follow me? Okay, cool. And the next time we check if we can go into our while loop again. So are we able to go through our while loop again with bar1 equaling 1 and bar2 equaling 2? I mean, equaling 1. Right, so it satisfies this condition, the first one, and 1 divided by 1 is greater than 0. So we're able to enter the while loop again. And so bar1 is 2, and then bar1 is now 0. Sorry, bar2 is now 0. So we check the while loop conditions, and bar2 has equaled 0. So we exit the while loop. So is everyone good on that question? Does anyone want to like visualize it out? We can check out the Java visualizer real quick.
Let's do that.
Yeah, let's do that. Okay, do you guys see my screen?
Yes.
Okay, so I'm gonna just format this nicely. And let's visualize it out. Okay, cool. So let's visualize this.
I'm sorry, I have a question.
Sure.
I mean, after the while loop, if the variable 2 is not equal to 0, I mean, how come we're gonna, work with the other side? I mean, it's end. I mean, it's end. I mean, we're using end, right?
Sorry, say that again?
I mean, I don't know how it's okay to compile that variable 2 is not equal to 0. I mean, variable 2 is 2, right?
Yeah, so, right, so what we're doing there is we're checking if their var2 equals 0. So it'll compile, because all it's going to do is say whatever value is stored at var2, is that equal to 0? If it isn't, it'll return true, and if it is, it'll return false.
So let's go through this visualization. We start off, and var1 is 0, and var2 is 2. Are we able to enter the while loop? We check, does var2, so this var2 does not equal 0 has to be true. So it would be false if var2 is equal to 0, right? So as long as var2 is not equal to 0, we can enter this while loop. And we check this division, and this division works out to be 0 divided by 2, which is 0. So we enter the while loop. And inside the while loop, var1 becomes 1, so you saw that change. And then var2 becomes 1 as well. And so now we go back to the while loop, and we see if we can enter it again. Are we able to enter it again? Right, var2 still does not equal 0, so that's good. We're good to go there. And then this division is 1. Which is still greater than 0, so we can enter the while loop once more. We enter it, var1 becomes 2, and var2 becomes 0. So then we go back to the while loop and we see if we can enter it. So in this case, var2, 0 does not equal 0. So that is false, and we have to exit the while loop. And then at the end of this whole method, var1 is 2 and var2 is 0. Did that help? Okay. Does anyone have any more questions on this one?
Thank you.
I'm good with that one.
Okay. So let's go on to the free response question. Okay, so we're going to do this one together. So this is a free response question given in a past exam. So the question is, a positive integer is called a self-divisor if every decimal digit of the number is a divisor of the number. So each number is evenly divisible by every one of its digits. For example, the number 128 is a self-divisor because it is evenly divisible by 1, 2, and 8. But 26 is not because it's not divisible by 6, only divisible by 2. So note that 0 is not considered to be a divisor of any number. So any number that has a 0 will automatically not be considered a self-divisor. So what we have to do.
So what's another example of a self-divisor?
Point 4.
Yeah, 24, because 24 evenly divides by 4 and evenly divides by 2. Cool. Is 163 a self-divisor?
Yes.
Yeah, let's see. So
163 is divisible by 3.
Yeah. Oh
I
no,
don't think so.
not 6. Okay, never mind.
Yeah, 163 is not divisible by 3 or 6. But odd numbers can be self-divisors. So is something like 55 a self-divisor?
Yes.
Yeah, because it's divisible by everything. What about 60?
Yes.
So if that zero is not considered to be
Wait, no.
as many numbers.
It's not, because we said anything that has a 0 is not going to be a self-divisor.
Oh.
Yeah. Because that, like, you get anything divided by 0 is going to cause you an error. Okay, so did we get the idea of self-divisors?
Yes.
Yeah.
Okay, so part A asks us to finish writing this method. We're going to take in a positive integer as our parameter, and we'll check if it's a self-divisor or not. So let's go through just the examples in the main method again, so like we can reinforce what a self-divisor is. So 128 is a self-divisor or not?
28 was.
Yeah.
Yes.
Yeah, you're right, it's a self-divisor.
No.
No.
No, right? Because it's not divisible by 6.
Yeah.
And 120?
No, it has a 0.
Okay, cool, awesome. So how did we figure out that 128 is a self-divisor?
So we see if it doesn't end in 0.
Yeah, we see if it has any zeros first. That's the first, right?
And we can do like 128 mod 2 if it equals 0. And then
Say that again?
we can do like 128 mod 2 and see if it equals 0. And then 128 mod 8.
Yeah, exactly. So you wanna mod it by each of the digits, right? So if it equals 0, that means it goes in evenly, right?
Yes.
Okay, does that make sense with everyone? How we should use mod in this problem?
Yes.
Okay, so we want to make sure that whatever the number that we have modded by each of its digits does not give you a remainder,
Yeah.
right? So that's how we did that here in this test. We mod by every single one of the digits, right?
Mm. Okay, so we can keep going. Yeah, let's check this. So what does this class print out? What is printed in the main method?
Print out 3 zeros.
What is printed in this one?
0.
Yeah. And same here, right?
Yeah.
Okay,
Mm.
cool. Yeah, perfect. And then we can check this one. What's printed here?
6 goes into 26. 2.
Yeah, 2. Okay, so we return false if the number has a 0. And then how would we go through all the digits in our...
Oh. It's an int, so it's like something you can call on an int to use like the tens or hundreds or ones place.
Okay, I like that idea.
Or-
What it is? How do we get the ones and tens and hundreds place of this number?
So
Does anyone have an idea of how to get each of the digits separately?
I guess like divide the number by 100, and if it returns 1 or greater, then it has that number of hundreds.
Yeah, that's a good idea. That's along the right lines. So you said to divide by 100, and what would
Yeah.
that?
I mean, for the 100 spot, if it, yeah.
Yeah, that's definitely the right idea. So, do we want to get the digits starting from the right or from the left? So for a number like 128, do we want to check if it's divisible by 1 first or by 8 first?
8.
Let's start from the ones place. So how would we get the rightmost digit of 128? So how would we get the 8?
I have no idea.
So it's like kind of like what you were saying before. To get the 1, you mod it by 100, right?
That tells you how many hundreds you have in your number. So what if you just wanted one digit? If you just wanted to see like how many tens do I have in my number?
So yeah, so for instance, if we were to mod the number 128 by 100, we would get what number? Yeah, you get 28. So we want to get just 8. So what's another number we can mod 128 by to get 8? Yeah, what did you say? Just shout a number out there. Let's give it a shot. We'll just try it.
10.
10? Okay, so let's do 128 mod 10 gives us what?
128 mod 10 gives you 28.
128 mod 8, so mod 10. So we want to see how many times 10 goes into 128. So 10 goes into 128. So it goes into 120 12 times, and there's a remainder of 8. So 128 mod 10 is 8. Right, so does everyone see how that works? How modding by 10 gives us 8? So that gives us the rightmost digit, which is what we want. So now how would we go about getting the middle digit, 120, like the 2? We just saw that modding by 10 gives us the rightmost digit. So what do we need to do to the number? Yeah, so like once we've checked if 128 mod 8 is like even, if it gives us 0 or not, we want to now check if 128 mod 2, or like, sorry, my bad, I took that back. So we want to check if 128, like if 2 is evenly divided, right? So how do we get the 2 now? Like once we finish dealing with the 8.
Oh, what if we subtract 1 from 10, which will be 9? So 9 divided by 128 would be, we have the remainder of 2, right?
128 mod 8.
So basically we're dividing 128 by 9, and then we're going to get 14 in the remainder of 2.
I think that works in this case, but I don't think that's the best way to like keep subtracting from. How do you go about getting the 1? I don't think that's like, I think the idea is that we definitely want to keep modding by 10 because we know that works. We know that will always give us the rightmost digit. So if we know that always gives us the rightmost digit, so for 128 it gave us 8. So now what's it like for if we wanted 2, we might have to do something to the number 128 to get 2. Yeah. So we had 128 and we modded it by 10, we got 8. So now we're sort of done with this number 8. We don't care about it. We checked if it's divisible or not. So we can like sort of chop off 8 from the number we were given. Chop off 8, we're left with 12, right? 1, 2. So what is, so if we were to mod by 10 again, what would that give us? Yeah, so if we were to mod 12 by 10, that would give us 2. Right? So that's what we wanted. We wanted to check now if 2 was divisible by, if 128 is divisible by 2. So that works. I think, so we definitely want to keep modding by 10. But how did we chop off, like I just chopped off 8, but how do we do that mathematically? So if modding gives us the remainder, what gives us, yeah.
Could you mod 108? And that gets, wait, never mind. That would get 20, but then
But we want,
not. Yeah, I know. Never
Good
mind.
try, for sure. That's a good try. Think about using other mathematical operations besides mod. Mod always gives us the remainder, but in this case, like, yeah, we want, so remember how I said we chop off 8? We chopped off 8 because 8 was the remainder, and we kept 12 because we had modded by 10, 12 times 10 plus 8 is 128, right? So we kept 12 because 12 is like how many even times 10 goes into the number we have. Does that make sense? So what is the opposite of multiplication?
Division.
Okay, so think about how division would allow us to chop off 8.
Oh, percentages.
So does anyone have an idea?
Would because it's an integer, if you did like a number divided by 10, it'd be like 12.8, but it would only keep the whole number part.
Sorry, I couldn't understand you. Can you repeat that?
Okay, so if you did like 128 divided by 10, that would be 12.8. But since it's like integers, would it just take away like the decimal part?
Yeah, exactly. That's exactly right. Yeah. So if we did 128 integer division and we divide it by 10, that would give us 12. That like rounds down. Sorry, it truncates. So by truncating means it like gets rid of the decimal. And in this case, the decimal we already used and we already checked because we already modded it by 10, right? So the idea is once you always want to mod by 10 so you can get the remainder and then check if that, like you could get the digit and so you want to check if that digit is divisible into the number. And then once you're done using it, you divide by 10. And then you would do the whole process again. So does that make sense to everyone?
Yeah.
Yeah.
Okay, so we know we have to keep doing this until like the number of digits that we have in the number. So for 128, we do it 3 times. For 8, 2, and 1. So what kind of loop do we want to use?
A while loop?
Okay. Anyone else does everyone think we should use a while loop?
Mhm.
Okay, let's check it out. Yeah, so why do we use a while loop? So we're not going to run.
You know how many digits are in a number.
Exactly. We're able to take in any positive integer, right? So we don't want to set how many times we should run our for loop. We should just do it the number of digits that are in the number.
Yeah.
So let's answer this question. What should you use as the condition in your while loop? So how many times do we want to keep, like, what is the condition of our while loop going to look like? Right, so the first, what are we going to be doing inside of our loop?
We want to see if each digit, when it's modded, will equal 0.
Yeah, so exactly. So that'll be the if statement in our while loop. Perfect. So
Sorry,
what
my
would-
dog is.
so what would be the condition for when we would break out of our while loop?
Oh, when it doesn't equal 0.
When it
When it doesn't equal 0.
when it doesn't equal 0. So that would be in our if statement, right? Inside of our while loop. So we would mod the number we were given, like the digit. We'd get the digit by modding the number by 10.
Mm-hmm.
And then we'd check if that digit, if that digit is 0 or not.
Yes.
But inside the while loop, we're also going to be, so that's what we're going to do inside of our while loop. So when do we do the division? Like when do we, once we've checked, when do we do the division? Okay, so we're gonna do the mod inside of our while loop, and then outside of our while loop, we're gonna divide by, inside of our while loop, we'll also divide the number by 10, and like chop or like truncate the number, chop off the digit we just modded by.
Okay.
So the number, how many times do we want to keep dividing the number?
Until all the digits are done.
Sorry? Can you repeat that?
Until we did all the digits.
Yeah, until we did all the digits. So 128 would start at 128, and then we divide by 10.
Mm-hmm.
Then we would get 12. And then if we divide by 10 again, we would get what number? If we divided by 12 by 10, what number would we get?
1.2.
Yeah, 1.2. And so that becomes 1, right? Because it truncates.
Yeah.
So we would enter the while loop once more. We would check for 1. And then we would divide 1 by 10 again. And what does that give us?
0.1.
Yeah.
0.1. So that would just be 0,
Yeah.
right?
Mhm.
So then we would exit out of our while loop because we obviously know like 0 is not it.
Yeah.
So what would be the condition of our while loop?
Current number is greater than 0.
Greater than 0? I heard that. Yeah. Okay. Let's. Awesome. Yeah. So for instance, 128, we kept dividing 128 by 10 until we reached 0, and then we exited. Cool. Does that make sense?
Yes.
Okay. So yeah. So because we're sort of at the end of our session, let's watch the video now that we have the basis of how this works. And you guys can always go on the ebook and try writing it yourself, but we can watch the video and see how it works. Is that cool?
All right.
Okay. So I'm just going to play this.
You need to first create a temporary variable that holds what the current number was, because we're going to be taking the rightmost digit off each time we loop through it. So we can call that anything. I'll call it cur number. So it starts off equaling number. Then we want to loop, use a while loop, because we don't know how many digits this has. We don't really need to know. So while the cur number is greater than 0, so while it still has a digit in it, we want to do the following. So we want to check. We want to get the rightmost digit. So we're going to need something to hold the rightmost digit. Start off at 0 here. And the way that we get the rightmost digit is using the remainder when we divide by 10. So cur number modulo 10 will give us the rightmost digit. And if that digit is equal to 0, return false. And if the number, cast in number, modulo the digit, not equal to 0, return false. Otherwise, we're going to, we know that that was evenly divisible, and we're going to chop off, we're going to change current number. So current number is going to change. And we want to get rid of that rightmost digit because we already tested that one. So we do that by dividing by 10. Remember, with integer division, it's going to throw in a remainder. So this will effectively get rid of the rightmost digit. So if we get through all of that, the while loop finishes, then it was self-divising. So we would return true. So return false if it's 0, return false if it's not evenly divisible, and we return true if it is. So we hit run to test it. And 128 should be 2, and the rest should be false.
Okay, so that was like a quick explanation of what we went over. We can, does anyone have any questions off the bat of what we saw in the video? Does anyone, did everyone sort of follow along? That was kind of fast, but yeah, we can go through it next time if you guys want to try it out yourself, now that you have like the basis. Does anyone have any final questions about this question or any of the multiple choice ones we did, or just loops in general? Okay, so it looks like not. So thanks for coming, guys. We hope this helped, and it's always good to get practice doing questions that have been on the exam. So we'll post the link to this FRQ, this free response, in the GroupMe so that you guys can go through it and like answer it yourself and like try it out with test cases. Feel free to schedule a one-on-one. Yeah, and we'll see you next week.
Okay, bye-bye. See ya.
Thanks. Bye.
Thanks for coming, guys.
Mhm.
Bye.